Hi guys, welcome back to this series of discussion on statics of rigid bodies. Our topic for today is all about the principle of moments, the concept, and how this principle is used in the computation of moments. Sa huling bahagi ng presentation na ito ay naghanda tayo ng isang sample problem para lalong makatulong na maintindihan natin ang application na ito. Kaya sana guys ay patuloy niyo sundan ang series of lecture na ito sa pamamagitan ng pag-click, subscribe at notification buttons para laging ma-inform tayo tuwing may bago tayong uploads. Puntahan natin ang topic natin guys. Ang topic natin ngayon ay principle of moments. Tinatawag din siyang Varignon Theorem dahil ang nag-formulate ng konseptong ito ay si Pierre de Varignon. So, sabi nga, ang isa daw sa pinakamahalagang principle sa mechanics ay itong tinatawag nating principle of moments. Paano ba ito na-state? Ang sabi dito, ang moment daw ng kabuuan or moment of the resultant or the moment of the force, it is equal to the sum of the moments of each component. So, to explain this concept, let us imagine that we have here 2 points. We have point O and point A. So that the position of point A from O is described by this position vector RO sub A. And let us assume that at point A, there is a force F that is directed as shown in this direction. As such, makukuha natin yung moment ng F about O using the vectorial notation formula. That moment is equal to the cross product between ROA and F. Now let us imagine again also that there is another force Q that is also directed from A and directed in this direction. If Q passes through A, therefore F and Q are intersecting vectors. Now the moment of Q about O can be taken using the vectorial notation as M ROA cross Q. If both are passing through A, then F and Q are intersecting vectors. And therefore, the resultant can be taken using the parallelogram concept. Now let us try to show that resultant by drawing the parallelogram. Imagine that we have here a line parallel to F and another line parallel to Q. Therefore, the diagonal of that parallelogram is our resultant. Now, the resultant is taken as the product or the sum of F and Q, and vectorially, this is represented by R equal to F plus Q. Okay? Now, as such, if R is the resultant of F and Q, then R can replace F and Q, so that we shall have here the replacement of F and Q. Okay, and the moment of R about O can be taken using the vectorial formula that it will be equal to ROA cross R. But R is equal to F plus Q. Kaya kung sasubstitute natin itong F plus Q sa R, the moment formula, then our moment equation becomes ROA cross R, which is equal to ROA cross the quantity of F plus Q. Now, if we are to apply the distributive property of cross product, then ROA cross F will be equal to this product, while the other one, ROA cross Q, will be taken individually. And kanina lang, dinescribe natin that this ROA cross F is the moment of F about O, while this ROA cross Q is the moment of Q about O. Hence, we have now generated a formula that describes the relation between the moment of R, the moment of Q and F, having Q and F as the component of R. And in this relation, we can make a generalization that the moment of the resultant is equal to the sum of the moment of each component. At yan nga yung tinatawag nating principle of moment. Para may paliwanag ng mas detalyado ang application nitong principle of moment, let us try to imagine that we have here the Cartesian plane described by the origin. Somewhere here, meron tayong origin. Here we have our x, and here we have our y. And along this plane, let us imagine that we have here the line of action of the force where F, having a magnitude of F sub m, is directed. Assuming natin that itong point na ito ay point C, na kung saan ang shortest distance from O to this line is defined by D. Hence, if you're going to consider the scalar approach in dealing moments, then the moment can be taken as the product of the magnitude of F and the distance of that F from the axis of moment, and that is equal to F sub m multiplied by D. And it will be causing a rotation in the counterclockwise direction. Yun. If we are to consider the vectorial approach in dealing moments using the principle of moments, then we need to have our position vector of C from O, and let us define that as ROC. And therefore, the moment of F about O will be taken as the cross product between ROC and Q. Now, kung sakali ay i-resolve natin itong F na ito into components parallel to Y and parallel to X at point C. So what will happen? We have this component. We now have the Y component of F represented here as F sub Y sub M, and the X component of F represented by X sub M. And you will notice that the distance of F sub X sub M from the axis of rotation will now be defined by Y sub C, while the distance of F sub Y sub M will be defined by this distance. We call that as X sub C. And if we are going to examine the rotational effect of F sub X and F sub Y about O, you will notice that the components of the force have the same turning effect about O, and they are both in the counterclockwise direction. Now, we are adding them algebraically using the right-hand thumb principle. Ano ba yung right-hand thumb principle? Na-discuss natin ito last time na we will be treating positive kapag sumusunod siya do sa right-hand thumb concept. And that is, having this counterclockwise direction if we are looking from the axis of rotation, to be positive. Hence, the moment will become the moment due to F sub X sub M having a moment F sub Y sub M having a moment arm of X sub C, and that will be F sub Y sub M multiplied by X sub C plus the moment due to F sub X sub M having a moment arm of Y sub C, that is F sub X sub M plus Y sub C. And this becomes now the moment of F about O, considering the effect of the Y and the X component of the force, using the principle of moment that the moment is equal to the sum of the moments of the individual components. Now, subukan naman natin na itong F na ito ay i-resolve natin somewhere below this point. By considering additional points along the line of axis. Subukan natin na mamili tayo ng points. Lagyan natin siya ng points ng A, somewhere here. Lagyan natin ng point B, itong point na ito. Ito naman yung point din natin. At lagyan natin ng point E somewhere here. And we try to consider that this force be resolved at point A. At the point below the x-axis. At piliin natin itong point A na ito. makatuwid, this is what we will see. Okay, the f now is resolved at point A. It is our y component, it is our x component, and you will notice that, okay, the x component will have a perpendicular distance from O equal to y sub A, while the y component has a perpendicular distance from O equal to, okay, x sub A. At kung pag-aaralan natin yung turning effect that this f sub y and f sub x is causing or are causing about the axis of rotation at O, you will notice that the components of f have moments in O in the different or in opposite direction. At makikita natin that f has or is causing a counterclockwise moment. Itong f na ito, nakita natin, no, is producing or is causing a tendency to rotate in the counterclockwise moment about O. While, okay, the x component is this one is or has a tendency to rotate in the clockwise direction. So that if they will be added algebraically using the right hand thumb principle that that is positive when turning in the counterclockwise direction, then the moment of f about O becomes equal to f sub y sub m multiplied by x sub a. That is the moment due to the y component of the force, minus the moment due to x component of the force, which is clockwise in sense, and therefore that is negative. And I made it to be different, to have a different color for us to give emphasis that the direction of this f sub x sub m at this point is already in the clockwise direction. And this becomes now the moment of the force about f taken from the moments of the components now resolved at point A. Now, subukan naman natin na itong force na ito ay i-resolve at point B. Where B is called as the x-intercept of the force, or the point at which the force will cross the x-axis. Now, let us try to show it that this be resolved at that point. Here is now the force resolved at point B. Here is our f sub y. Here is our f sub x. You will notice that f sub y will now have a perpendicular distance from the axis of rotation equal to x sub b, while f sub x will have no moment arm because it will just pass through O. And you will notice that the y component of the force has counterclockwise moment, while 1, and it is producing a counterclockwise moment, while the x component of the force has no moment because its moment arm is 0. And therefore, the moment of the force is only caused by the y component, and that is equal to the moment of the force about O equal to the product of this f sub y and f sub y sub m multiplied by x sub b here. Okay, now suppose that this force will now be resolved at point D, na kung saan D shall be called as the y-intercept of the force, or the point at which the force intersects the y-axis. Now let us try to do it. Let us try to resolve it. There, it is now the force, and you will notice that the x component of the force will now have a perpendicular distance of y sub d, while the y component of the force will have no moment arm because it will just pass through the axis of rotation. Okay, and that the x component will produce now a counterclockwise moment about O. So this force will now be producing a counterclockwise moment about O, while the y component, this y component, because it will just pass through O, will have no moment because that has no moment arm, and therefore the moment of the force is only caused by the x component. As such, the moment of the force now can be computed as the product of this f sub x sub m multiplied by the moment arm, which is equal to y sub d. What about if the force is resolved at another point, say for example to the left of the y-axis, and we select point E? Okay, try to move it somewhere here para makita natin yung point E. Okay, we now try to resolve this force at point E. Let's do it. Okay, here is our force resolved at point E. And you will notice that F sub y sub m will now have a perpendicular distance equal to Fx sub b, while the F sub x sub m will have a perpendicular distance of y sub b. And if we are going to examine the turning effect of F sub y sub m and F sub x sub m, okay, you will notice that, okay, they will have a turning effect in the opposite direction. This component, F sub x sub m, will have a turning effect in the counterclockwise direction. You'll notice that, okay, that is the turning effect of, okay, the F sub x sub m. While the F sub y sub m, the y component, is or has a turning effect in the counterclockwise direction. Here is the turning effect of this, okay, F sub y sub m. And because they are in the opposite direction, okay, one of them will okay, be negative because it will not, okay, conform with the right hand thumb principle. Now, if we will be adding them algebraically, again using the right hand thumb rule that is positive when it is, okay, directed in the counterclockwise direction, hence our moment becomes equal to F sub x sub m multiplied by y sub b, which is positive, minus, okay, F sub y sub m multiplied by x sub b, because that is clockwise in sense. So again, I have, okay, made it a different color because I would like to give emphasis that this becomes negative because the turning effect of F sub y at this point, when it's resolved at point E, is already in the clockwise direction. And so that's how we explain the principle of moment, how we can compute for the moment, okay, using the components. To further explain and to support that concept, it would be better to consider having a sample problem. And let us take this example. Tingnan natin itong problem nito. A 4 kN force F is applied at point A. Compute the moment of F about point O, expressing it both as scalar and as a vector quantity. Second, we are also required to determine the coordinates of the point on the x and y axis about which the moment of F is 0. Okay, let us try to show the illustration. Now, here is the illustration. We have here the x-axis, which is measured in meter, and you have here the y-axis measured also in meter, and you have here a point having a coordinate of 1.2, 1.5, and the force is directed down to the left at an inclination of 3 vertical, 5 horizontal. So in this, we are required to determine what's the moment of this about O, and what are those points in the x and in the y-axis where the moment is 0. Later on, I will explain this question, determine the coordinate. Okay, so let us now try to work on this problem by, okay, showing two different solutions, because in this problem we are required to express it in both scalar and a vector quantity. So we have to show it in two different solutions. Let us have the solution number 1. Okay, using a vector approach, given the direction of F in terms of the slope, we now solve natin itong x and y component. Ipakita natin itong F nito dito, okay, kung saan ang kanyang, okay, magnitude ay 4 kN at meron siyang slope na 3 vertical at 5 horizontal. Itong angle na ito, tawagin natin itong theta, and from this ratio, masolve natin itong hypotenuse ng slope ng triangle, and that is equal to the square root of 34, because that comes from 25 plus 9, so that's square root of 34. So from these elements, we can compute or express the components of F by using the parallelogram. So since that is x and y, so makukuha natin yung parallelogram sa magitan ng pagdraw ng rectangle. Okay? So that itong component na ito ng rectangle will be our F or the x component, ano? At ang kanyang magnitude will be F sub m cosine of theta sub x. But, ano ba itong theta sub x? Cosine of theta, cosine of theta na ito. Ang cosine of theta mula dito sa triangle na ito will be 5 over the square root of 34, di ba? Kaya, pag sinubstitute natin yan, that is equal to fx equals 4, having the magnitude of f sub m, and this cosine of theta, that is 5 over the square root of 34. Similarly, this component will be the y component of the force. That is called this y, f sub y. As such, f sub y will be equal to fm sine of theta. And if we are going to look at this theta here, sine of theta will have a value equal to 3 over the square root of 34. So that if this will be substituted here, meron tayo ngayong f sub y, so this is f sub y, f sub y equal to 12 over the square root of 34. Okay? So, pagkatapos, pakita natin itong f sub x at f sub y dito para ma-apply natin yung ating principle of moments. Makikita natin dito that if this is point A, ang distance, okay, ang moment arm nitong f sub y will be equal to 1.2, while the distance of this f sub x from the axis O will be this distance of, okay, how much? 1.5 coming from the coordinate. Diba? Now, if we're going to use the principle of moments, paano ito i-apply natin? Ang moment daw ng force shall be equal to the sum of the moments of the individual component. So if we're going to substitute that value, then the moment of the force shall be equal to f sub x, 1, multiplied by the moment arm of 1.5. Okay, and they are producing in different direction. Ano? You'll notice that f sub y is producing a clockwise moment effect about O, therefore that would be negative, minus f sub y multiplied by this 1.2. Now, if we will be substituting the value of f sub x, which is this one, and the value of f sub y, which is this one, again, this is not x but y. Okay, so our f sub, the moment of f about O will be equal to 20 over the square root of, okay, 14 multiplied by 1.5 minus 12 over the square root of 14 multiplied by 1.2. Now, if we will be simplifying it, okay, we can take the product. This becomes 20 multiplied by 1.5 is 30, while 12 multiplied by 1.2 is 14.4 divided by the square root of 34. Simplifying further, this becomes, okay, 15.6 over the square root of 50. And this is turning, okay, turning in the counterclockwise direction because, okay, it is, okay, located above. Okay. Now, what about the second method? Let us try to consider the second method. Okay, method 2, we will be using here the vectorial notation. And what shall we do? Okay, we need to have, okay, the position vector of A from O because we have, okay, the formula of the, okay, moment as the position vector ROA cross F. So we need to show what is this position of A from O. So let us, okay, define that position. That is equal to, okay, ROA, which is equal to 1.2 minus 0, that gives us 1.2i, and 1.5 minus 0 gives us 1.5j. And what is our F? F is already taken as, okay, since this is our x coordinate, x component, so we'll simply multiply it by, okay, simply multiply it by I, while this one will be multiplied by j, that is equal to 20 over the square root of 34i minus 12 over the square root of 34. There must be j here. There must be j. Okay? And so, okay, the moment, therefore, yun, becomes equal to, or the force becomes equal to, okay, getting the least common denominator or the common factor, that is negative 4 over the square root of 34. I will have here 5 plus 3j. And so when this will be substituted here, the 2 will be substituted dito. Substitute natin dito yung ating moment ngayon becomes equal to 1.2i plus 1.5j. So yun. Cross negative 4 over the square root of 34 times the quantity 5i plus 3j. ito naman yun. Diba? Ngayon, kapag ginamitan natin siya ng cross-product multiplication, okay, ano ba mangyayari? Okay, ano natin? Itong dalawa, okay, apply natin yung distributor na, kasi kapag ito tsaka ito multiply natin, 0 na yan kasi I cross I is 0. Diba? Kaya matitira I cross J, which is equal to 1.3 multiplied by, okay, 3 is 3.6. Diba? Tapos ito naman, 1.5 multiplied by this one. Diba? And that is equal to 7.5 J that I supposed to be. And so that becomes negative K. Okay. So when this is simplified, so what will happen? So we shall have here, okay, result of 15.6 over the square root of 34 multiplied by K. So bakit nagkaroon K? Kasi it is expressed in terms of the vector. That this is the magnitude, that is the direction. The direction meaning it is directed towards the positive z-axis. Kumbaga, ito yun, nakaturo sa atin yung axis z. Now, solving for the second question. Let's go back to the second question. Tingnan natin itong tanong na ito na determine the coordinates of the points on the x and y axis about which the moment is 0. Ano bang ibig sabihin yan? Tandaan natin, ano? Pag sinabing moment is 0, ang ibig sabihin nun, okay, that point passes through, that force passes through that point. In the x, ito yon. In the y, ito yon. Kaya this refers to the x and y intercept of the K force. So, imagine natin that this point is the point where the force intersect the y-axis, and therefore we shall be calling it as the y-intercept. Whereas, we are going to draw the line of action, this point will now be called as the x-intercept. Now, let us now try to resolve f at this point. Resolve natin siya dito, no? Yon. Sa mga tuwid, lalabas na itong y-x component natin, ang kanyang moment arm from the axis will be, okay, y sub I, or the question that we are, the coordinate that we are being asked. Diba? And f sub y will have no moment. Therefore, if we are going to take the principle of moment, the moment of the force, which is equal to 15 over 6, ano, and we will be taking the magnitude only, ano? We will be taking the magnitude, shall be equal to f sub x multiplied by y sub I. And f sub y will have no moment because this has passing through O. Now from here, we can substitute. Ano ba yung ating f sub x? Kanina, itong f sub x ay, nasolve natin na kay 20 over the square root of 34. And 34 natin will cancel each other. Okay? At matitira, okay, y will be 15.6 over 20, which is equal to 0.78. Subukan naman nating i-resolve itong f at this point na kung saan nag-cross ang force sa x-axis. Okay? So, mapapasin natin na yung f sub y will have no moment because it will just pass through O. The moment arm is 0. While f sub y will have a moment arm equal to x sub I, which is what we are looking for. And you will notice that the moment due to f is only caused by this f sub y, whose perpendicular distance is x sub I. So that if this will be equated with the moment of f about O, this is our moment. And substituting that value of the moment, formula for the moment due to f sub y, which is equal to f sub y times x sub I. Kung sa-substitute natin itong f sub y equal to 12 over the square root of 34, yung square root of 34 dito will cancel each other. Kaya lalabas, x sub I is equal to 1.3. Therefore, yung coordinates of the points on the x and y axis about which the moment is 0 are the following. The first is 0 at 0 at 0.78, ito yon. While the other one is 1.30, which is this point. So, guys, sana ay nasundan ninyo yung discussion natin about the principle of moments. Kaya, muli ko kayong inimbitahan na mag-subscribe para tuloy-tuloy nating nasusubaybayan itong ating series of lecture. Again, thank you very much for watching.